So now we're going to look at a very important family of sequences, the sequences r to the n, where r is any number that you like to put in there between 0 and infinity. For example, if r is 1/2, the general term of this sequence is 1/2 to the n, and if r is 4, the general term of the sequence is 4 to the n. Whether these sequences converge or diverge depends on the actual value of r. And we're going to find that they converge for any value of r between 0 and 1, and they diverge for any value of r bigger than 1. How could we show this? Well, we need to calculate the limit as n goes to infinity of r to the n. And whatever the r is, the function r to the x makes sense here as x approaches infinity. This limit is equal to the limit as x approaches infinity of r to the x, because r to the x is a function for x bigger than 1. Now we can rewrite r to the x, recall from our exponential or our definition of r to the x, that's e to the x times the natural log of r. So we're looking at the limit as x approaches infinity of e to the x times the natural log of r. And now remember, the natural log of r depends on the value of r. It's equal to 0 if r equals 1. It's less than 0 if r is between 0 and 1, strictly. And it's greater than 0 if r is bigger than 1. So e to the x times the natural log of r has a positive power if r is bigger than 1, in which case e to the x times the natural log of r goes to infinity. If r is actually equal to 1, it's always e to the 0, so the limit as x goes to infinity of e to the x times the natural log of r is 1 in that case. And if r is between 0 and 1, then the natural log of r is negative, so e to the x times the natural log of r goes to 0. So the limit of our sequence is 0 if r is less than 1, it's 1 if r is equal to 1, and it's infinity if r is bigger than 1. And of course, if r is 0, 0 to the n is always 0, so the limit of the sequence is 0. So the sequence r to the n, whether it converges or diverges, depends on the value of r. It converges for r values between 0 and 1, including 0 and 1, and diverges to infinity if r is bigger than 1.